Hello again, how are you doing? It's me, Murad Sultan Ezouidi, the pioneers in methods. Okay, today my kids will learn how can you solve the fifth degree from equation using Ezouidi theorem. Okay, I'm of course addressing to those who have smart minds and who have curious about mathematics research. Okay, and who are curious to find out the exact roots without using method Newton or uh, rational theorem or other approximation method that will give you wrong answers. Okay, but Zwedi theorem will help you to find the exact roots. Okay, it's an occasion for you professors and students and colleagues to learn from you. How can you use Zwedi theorem? Okay, and you will be able to solve, let's say, whatsoever the degree of the equation that you work with or the m degree from the equation. Okay, so Murad, I'm going first to use this one. Yes, let's see. Okay, this one. Okay, now I'm telling you something, my kids. As we told before, welcome to Murad Sultan Ezouidi, Pioneers in Methods, HSM. As you know, that I'm Murad Sultan Ezouidi, Pioneers in Mathematical Research and author of numerous books on solving Coulomb equations based to the power of n. Dive in the uncharted waters of math with our groundbreaking solutions to Coulomb functional, experience math, experimentation, and engineer conceptual processes with insights that defy conventional thinking. Just join a community of bold explorers ready to find what's possible, be inspired, be challenged, and elevate your mathematical skills. Subscribe now, professors and teachers and colleagues and learners and students and my kids. And let's navigate the seas of human function together, discovering new horizons in the world of mathematics or in the world of mathematics. Okay, this is me, Murad Sultan Zwidi. I will now share, let's say, the screen with you, my kids. Okay, so that you'll be able to see what happened while using the Zwidi theorem and how we can apply it. Okay, go wheresoever you want to travel or learn or study, you will never see this method before. Okay, I will see. I will give you, let's say, addition or just make or make new thing like that. Addition, optimization, addition, optimization. Okay, édition, édition, universitaire, uni- universitaire optimization, universitaire optimization. That's this one. I will let you know how can we solve a fifth degree from the equation where all, let's say, okay, no need for this one. Okay, reject both. Okay, login. Okay, connect. Okay, these are my professors and my colleagues. These are my projects, my books of mathematics. Okay, so let's see this one. Yes, okay, this is my paper. Okay, all right, okay, just okay, go back like that. I will go to project. So we see these are my books. in mathematics, and I got my ISBN. Okay, these I will use this book and apply the theorem of Murad Sultan Ezouidi. If you buy this book, you will find everything, and you will apply it for any anti-glyphon equation. Okay, you see this one 10 to the power 18, we solved it, and we got our ISBN. Okay, so modified. Okay, this one they give me, let's say, theory. Okay, modify. Okay, this also, and new theorem, modify project. I will modify after. Okay, so I will use this one. Okay, this is my book. Okay, this is the book. You see, en tant que professeur de mathématiques, créer un sentiment d'enthousiasme pour l'enseignement de la géométrie, de l'algèbre, du traitement de données et des probabilités de quelque chose qui me passionne vraiment. Je crois que le processus d'apprentissage est en quelque sorte crucial pour les jeunes, car il permet d'éduquer les bases de l'avenir dans une attitude positive. C'est le rôle de l'enseignement. Okay, so this book had been written and discovered by Mr. Morris Fanguidi and revised by the Professor Muhammad Radewi, my best professor in mathematics, while I was in the school. Okay, so it's called New Theorem and Methods for solving or searching the exact roots of any ambiguous equation. I will go down. This is my copyright for the book. Okay, this is my copyright you see here, but this one had been written in French. I already prepared 10 books written in English, and I sent to European edition of university, European edition university in Iraq to publish them. Okay, so this one you see copyright Murad Sultan Ezouidi and Muhammad Rajawi. So no one can use my theorem. Okay, but it's an occasion for you to learn how can you work with polynomial to the power n. Okay, let's focus on the formula that I really use now. Okay, like that, I see. And each theorem, every theorem has been demonstrated with three methods. Okay, with three methods. So, means this book is very rich for professors and for researchers to understand the relationship between original Nth-degree equation and the new Nth-degree equation. Okay, and then you figure out the correct answer, the correct roots. Okay, I will apply now the theorem. I'm going to show you the theorem. I will apply this one. Okay, this is also has to be applied, or this formula, both different formula, but they will give you the coefficient of the Newton to the power n. Okay, and also I'm going to use this formula. Okay, where is it? This one. Okay, just a moment. Yes, this one. You see this theorem. You see theorem of Mr. Murad Sultan Ezouidi. You see this? Okay, so it's the same as that. I will show where is it, my book? Here. You see this one, my kids? I will show you the formula here. Okay, I will go to 20, question 20. We solved the 21, I thought I would see. Yes, okay, this is the thing that I'm going to tell you about. Okay, you see this formula, my kids? I will show you. This one, you see? This one is as that. This is the theorem of Mr. Murad Sultan Ezouidi. Okay, S subscript k minus 1 over r equals the sum from 0 to k combination n minus r plus k minus r n raised to the power r between parentheses 1 to the 0 for q raised to the power k minus r l r minus q LR minus 1 of order 2. This is the Ezouidi theorem, or Murat Sultan Ezouidi theorem. Okay, this is the same as that matrix. Okay, what is it? Where was the okay. This one? Yes, it's the same as that. Okay, I will make bigger for you. Okay, I will make it bigger so that you can see. I will put it this one here. You see this one? Okay, for author use only. This formula is a spare for the R. When putting P equal K minus 1, it will be S subscript K minus 1, and P is equal K minus 1. K minus 1 plus 1 is K. Okay, clear? So this is how to do it. Okay, also هنا if P equal K minus 1, this will be K, this is, it will be okay, K from 0. I will just replace K with R, with P with K, okay, and it's the same formula. So I'm going to read this theorem number 6. Let P of n, Pn of x equal the sum from K to n minus 1 of 42 raised to the power K times L K minus 1 of 42 x n minus K of polynomial to the power of the form n q, where q, let's say, denotes the order, okay, and not the highest power, not its highest power. Okay, so how we close this one? Now I'm going to solve this question, my kids. Okay, I'll just come like that. This is polynomial to the power 5. P of x equal x raised to the power 5 minus 125 x raised to the power 4 plus 625 6,250 x cubed minus 156,250 x squared plus 1 million plus 19 million, no, plus 1,953,125 x minus, okay, minus 58,593,750. So I'm going to write this as in its standard form. It's clear that it's going to the power 5. I'm going to find the S subscript R, where R ranges from minus 1 to 4. Just calculation, my kids. Here, the calculation will be key for you. You will use the discrete formula of Murat Sultan Ezouidi, and you are going to see that S minus 1 is equal to 1. Okay, this one. S0 is equal to 0. S1 equals 0. S2 equals 0. And S3 equals 0. Okay, and S4 equals 0. Means you will obtain a new fifth uniform equation that has to be written as x raised to the power 5 minus 0.42 x raised to the power 4 plus s1 of 42 x raised to the power 3 minus s2 of 42 x squared plus s3 of 42 x minus s4 equals 0. So this, my kids, S1, just substitution will obtain that is equal to 0. You can use calculator now because you are the mates enough, you are smart, okay, to calculate this one. Okay, now to find S3, just use the Ezouidi theorem, and of course you are going to make substitution, and you will obtain that S2 is equal to what? S2 equal to 0. Okay, therefore, to find the S3, you should put the K equal 4 in the discrete formula of Murat Sultan Ezouidi and make your own calculation, and you will obtain that in fact S3 is equal to 0. For K equal 5 means you are going to find out the value of S4. Okay, just set K equal 5 in this formula of me, and then you are going to obtain that the value of S4 is equal to 0. Okay, so you can use your calculator or whatsoever and do your best. Now we cancel this. This is another example. Okay, I will cancel it. Okay. Okay, now my kids, this new polynomial to the power 5 has to be written as that. P of x equals x raised to the power 5 minus s0 of 42 x4 plus s1 of 42 x cubed minus s2 of 42 x squared plus s2 of 42 x raised to the power 1 minus s4 equals 0. all the S subscript K ranges from 0 to 3, 0 to 4, sorry, are equal to 0. This is, of course, yes, 4 is here. 3 is here. Okay, so this polynomial has to be written as x raised to the power 5 equal what? Equal 0. Means that x subscript from 0 to 4 is 0. Therefore, the roots of my fifth degree polynomial equation has to be written as that. 0 for the cube plus x subscript k ranges from 0 to 4, which is 0. So therefore 125, because this is x0, 125 divided by 5 gives 25 is a root of an order of multiplicity an order of multiplicity 5. Means this polynomial has to be written as x minus 25 raised to the power 5. Okay, this is uh, means that if S0 equals 0, S1 equals 0, S2 equals 0, S4 equals 0, S3 equals 0, except S minus 1, which is equal to 1, means your new fifth degree from equation has to be equal x minus 0 all raised to the power 5. Means 0 is a repeated root of order of multiplicity 5. And this also will give you the exact roots, the roots of your original fifth degree from equation with the same order of multiplicity. Let's go back to the question, to the audio polynomial. Okay, this one, isn't it? What is it? Okay, this is, sorry. Right. Okay, I will use calculator. We call that 125 divided by 5. Okay, it will be 225. I will make 25 raised to the power 5. Okay. Minus 125 times 25 raised to the power 4. Then plus 6,250 multiply by 25 cubed raised to the power 3. Minus 156 250 multiply by 25 squared. Okay. Plus 1,953,125 times 25 times 25. Okay, minus, okay, minus, okay. I will calculate this first. We have negative 15 minus, sorry, again, raise everything. Negative 15 times 125 raised to the power 4 plus 3 times 25 times 125 squared times 6,250 minus 250 times 125 times, okay, 156,250. Okay, okay. I will divide this by 625. Yes, 1,953. Correct. Okay. Then I will go to the last coefficient. The last coefficient. the last coefficient. So it will be last coefficient is that 25 raised to the power 5. Okay, is equal. Yes, this one is in fact equal. Sorry again. 9. Okay, copy. This one is that. And 3 and 4. Okay, I will check it here. So we got the calculator. Raise this. Okay. Again. Okay. 1 5. Yes, you see here. We get something here. Yes, in this formula. We called, okay, this is 5. So, it will be this number. Okay, I will do it now. So it will be 4. This is the first, this second, this is the second, the third, the third, this is the third. The fourth is 5 raised to the power 4 multiplied by 9. Yes, by this. 1 9 5 3 1 2 5. Okay, and this one has to be equal to 9 7 6 5 645. Okay, let's calculate this, my kids, first. Okay, what is the calculator? Okay, stand by. This is 4 multiplied by 125 raised to the power 5. Good me. Minus 25 multiplied by 125 cubic. Okay, multiplied by 6,250 plus 125 raised to the power 3, because this is 125, this is 125 squared raised to the power 3. Simplify this. Multiply by 6,250. Okay, there is minus. I will write minus. Minus what? Minus 625, because it is equal to 5 raised to the power 4. Multiply by 125. Multiply by 1,953,000. 1,953,125. Okay, plus, make plus 5 raised to the power 5. 5 raised to the power 5. Multiply by 9 million. Okay, multiply by 9 million. 9,765,625. So this one has to be equal to okay. Let's check again. Okay, 100. Okay, first square 125 is okay, plus okay 600. Okay, again 1,000, 1,000,000 Okay, this is 5, isn't it? Let's check. Okay, the first one, it will be, okay, 5 times 25, correct. The next is 10 multiplied by 25 squared. Is equal to 10. Yes, this one, okay. Again, also 10 multiplied by 25 raised to the power 3. Okay, correct. After that, we have, okay, 5 multiplied by 25 raised to the power 4. Raised to the power 4. Okay, equal 1953125, correct. And then we have my kids, 25 raised to the power 5 equal 976. Yes, correct. Okay. Now what's the problem here? Okay, so let's check. 4 choose 1. 4 choose 1. And the n is 5 now. 5 choose 5 is 1. I need to write it. Okay, 125 raised to the power 5, correct. Minus combination n minus 2. The n 5. 5 minus 2 is 3. 3 choose 3 is written, is 1. 5 squared. L0, okay, 105 raised to the power 3, correct. Times L0. 1, okay, correct. Plus n minus 2. 5 minus 3, 2. 2 choose 2 is 1. Set in here. 5 cubed. 125 squared times this, correct? Then there is minus. Okay, yes. Okay, minus what? Minus 1 choose 1. 5 raised to the power 4. 125 raised to the power 1. L3. L3 is that, correct? Plus 5 raised to the power 5 times L4. L4 9765. Yes, okay. Now check this equation. Okay, then I'm going to make a conclusion. Okay, what is it? Calculation. You do your best calculation, my kids. I will come back to you. So we have, okay, 4 times, 4 times, okay, 4 times 125 raised to the power 5 minus 25 multiplied by 125 cubed multiplied plus 150 plus 125 multiplied by 125 squared, okay, times 6,150, 6,150 minus 625 multiplied by 125 multiplied by 1,953, 1,953, 125, correct, plus 5 raised to the power 5, correct, all the parentheses, multiplied by 79 million. Again, see that? 79 million. No, 9 million only. 9 million 765,000 and 625. This one is equal. Equal. Yes. This one is equal, my kids. Sorry. This one is equal. Equal what? Equal. Okay, negative 29292 968750124. Yes, this is the value of S4. Okay, I will now calculate this one in corner view and we'll check. This is 4 times 125 raised to the power 5. Check with me if it's okay. Minus 25 multiply by 1 multiply by 125 raised to the power 3. Okay, times 6,250. All right, plus 125 cubed. You see, 125 cubed. Why? Because this is a square. This is raised to the power 1. 5 cubed is 125 to the power 1 times 125 to the power 2 is 125 raised to the power 3. Okay, then times. Yes, okay. This one now. This is the mistake. Yes, this one. You see, this is 152. Mr. Murad. You see the mistake. 156,250. Okay. Yes. Okay. خلاص. I will cancel this one. Then we check. Okay. Cut. Cut please. Cut please. Okay. No problem. Okay. Okay. Now we calculate this because my kid. This is L0. This is L1. This is L2. This is L3. This is L4. Okay. Okay. I will calculate this in front of you. So we told okay, we have 153 cubed. Okay, 5 square. Look here, 4 times 125 raised to the power 5 minus 25 times 125 cubed times 6,250. Okay, plus 125 raised to the power 3 times 15. Yes, times الحين times or times 156,250, correct. Minus 625 multiplied by 125 multiplied by 1,953,125 plus. Okay, now plus what? Plus 5 raised. Did I raise 5? 5 raised to the power 5. 5 raised, raised to the power 5 to the power 5 multiplied by 9,765,625 multiplied by 9,765,625. This one is equal to 0. You see? This is your pioneerism method model. Okay, so now I will go back. So you can see that x equal 0, it's x equal 0, it's called x root of the new fifth degree from the equation where the order of multiplicity is 5. Now the roots it will be 125 plus 0 divided by 5, which is 25. Okay, let's come here and you see here this one because the coefficient this one I will put in consideration. I'll take all of this. I'll see if I will cut it. Okay. Okay, now I will paste here. I will paste here. Control V please. Done. Okay. Yeah. Should smile at least, as Mr. Washington is here to help you to use his theorem and to solve fifth differential equation and to understand, let's say, the relationship between, let's say, fifth original fifth differential equation and the new fifth differential equation. Now I will put this here. So just this is 1 9 correct, but this one is 9 7 minus 9 7 9 7 uh, 9 7 6 5 6 6 5 6 25. Okay, erase this. Now my kids, you will use the calculator and you'll see this 25 is a root. Okay, it's a root, it's a repeated root, and the order of multiplicity is equal to 5, means you can write this p of x as x minus 25 all raised to the power 5. Okay, let's check. We have 25 raised to the power 5, because this is highest power, minus 125 multiply by 25 raised to the power 4, because this is 4, plus of course it's 6,250 multiplied by 25 cubed raised to the power 3 means. Then my professor negative 156,250 multiplied by the square of 25. Okay, so minus, okay, sorry, okay, minus this amount 156 multiply, yes, plus, not minus, plus, control P, plus what? 1 million, 953,145 multiplied by 25. Then minus this. Minus what? You can see this one. Minus 9797. 6565. 6262. 5. I will just subtract 9,765,625. This one is going to be equal to. And now, thank you for listening. We see the pioneers in method. Pioneers in mathematics. Thank you for listening, and I love you so much. I will, first of all, I finished this one. I will save this. Okay, it's clear. Okay, stop sharing. I will close this one, my kids. Then I will stop my. Okay, I'll stop this. Thank you for listening. This is Morad Sultan Ezouidi, the pioneers in methods. Okay, I will just send something to my friend, the best friend of mine, Mr. Ahmed. Okay, just a moment. Okay. Hello, Mr. Ahmed. How are you doing? It's me, Murad Sultan Ezouidi. Now I'm live. Okay. على المباشر يا أحمد. على المباشر الباحث التونسي. شفت صورتك يا الحبيب؟ شفت صورتك وين؟ ها؟ شفت ولا ما شفت؟ وين في مكة؟ تذكر. Thank you. Goodbye.